No, one is music. What is the other hobby?
Sir, my hobby is are watching cricket and learning new things.
Okay, learning new things. Okay, good.
So, Piyush, you have any question regarding science or want to say something?
Sir, I have a question.
Go ahead.
Sir, what is displacement?
Displacement is basically distance with the direction. Distance only has magnitude. Displacement has both magnitude and direction.
Okay, sir.
So if you want to say distance is scalar and displacement is vector. That is the definition of vector
Okay,
is
sir.
both direction and magnitude.
Thanks, sir.
Anyone else? Any questions?
Yes, Aryan or hello, Earth. You have any question? Hello, Earth.
Yes, sir.
You have any question regarding science?
No, sir.
So, Earth, please say something about yourself, first of all. So, sir will know. Hello, Earth. And I think Aryan, brother Rudra joined. Hello, Rudra.
Yes, sir.
Yes, Rudra, please say something about yourself.
My name is Rudra Kumar. My father name is Davin Kumar. I am 10 years old. I uh, I study in fifth grade. My hobbies are playing cricket and reading books.
Rudra, you have any question regarding science?
No, sir.
Okay, so right now, which chapter you completed in class 5, no? Yes.
Yes, sir.
Which chapter you completed in this session before summer vacation?
Sir, growing plants.
So, Rudra, can you try to say something regarding this chapter?
Sir, it is all about the plants.
Anyone is got a question?
No, sir, he is not asking question. Just saying that he read one chapter regarding growing plant. So, Rudra, So Rudra, can you say something regarding how to growing plant? This is
Sir, what?
how to growing plant in the earth. Hello Ankur, good evening.
Good evening, sir.
Yes,
Good
Ankur.
evening.
First of all, please say something about yourself, Ankur.
Sir, my name is Ankur Raj and I am reading in class 9th.
So you have any questions regarding science today?
No, sir, I have question of geography.
No, today
Yeah,
Saturday
go ahead.
evening. Okay.
Okay. What is the question?
Sir, how any Iceland is determined that it is of that particular country? How it is said?
How a country gets a shape?
No, how a Iceland is said that it is the Iceland of particular country?
Okay. Let me rephrase what you are saying. How you are talking about the country Iceland, am I right?
Yes, sir.
How Iceland is considered a country?
No, sir.
He's asking, I like, sir, which Iceland is from which country? How decided by our society?
Yes,
Okay,
sir. Yes.
Iceland is a okay. So there are two things. One is you are talking about the country Iceland. There is a country by name Iceland. Okay, in the Atlantic Ocean. The second thing is you are asking about an island full of ice. That's what I'm asking.
Sir, can I say?
Okay, go ahead.
Sir, an island is said to be belong to a country based on ownership and control. Country decided through like history, law and treaty, government control and international recognition.
Yeah, that's the correct answer. Any place, any small island, any country which has occupied that island from before, it is whoever takes it is his island. So before, if you are the first person to take control of that island, you own that island.
All of them totally silented.
So in good old days, no island was isolated place. Some tribe used to stay. No one was interested in taking those islands because of logistic issues. But during the period of colonization, they wanted islands as a staging units. So it was only during the period of imperialism where Britain, France, and other countries started occupying those islands. And those islands were mainly used for staging because the boats and ships could not travel for a long distance without food, without other items. So those places became a staging ground. They, they used to replenish their supplies, water, food, and keep moving. So that's how the island became prominent. So that's the reason most of the islands are owned by European countries who were imperialist countries once upon a time. And in US, before the fertilizer came into being, the crop, the basic need, the food was always in shortage throughout our history. So, in order to augment the food yield, they started looking for organic fertilizers. So, there were islands where there used to be a lot of bird shit. They used to call it guano. So those islands, they used to take these black people to dig up those bird shits like cow dung and use it as fertilizer. So all those islands which they had gone to do this, they became part of the US colonies. Now, when it was done in 1850s, 1856, I think, that no one thought about oil and exclusive economic zone, but because those islands belong to them, now 200 nautical miles around each of those islands, they can claim as exclusive economic zones, EEZ. And that is the reason why the islands become so important in today's scenario.
Very nice, sir. So, Ankur, which chapter you completed in science in ninth class before summer vacation? Can you say something regarding this?
Sir, I have read about the class matter and as pure in chemistry and cell in biology and physics, motion and rest.
So, those you read in physics, can you say something regarding this?
Regarding
Actually, I think Pius is also in class 9th, so it will go to, yes, discuss.
yes, sir, I can say something about that. I have read the chapter rest and motion. The rest, anything can said be rest when it does not change its position with respect to time. Then it is body or object said to be rest. But if the body or object change its position with respect to time, is known as motion. There are three types of motion: rectilinear motion, circular motion, and periodic motion. Rectilinear motion, the motion in which objects or body move in a straight line, is known as rectilinear motion. And in circular motion, object or body moves at a circular path. And in periodic motion, a body or an object move throughout a fixed path. For example, pendulum. Or sir, I have also read about distance and displacement. Distance, the actual path length covered by a body is known as distance, and displacement, the shortest path length covered by a body, is known as displacement. I have also read about the scalar and vector. A scalar is the quantity which have only magnitude, means value, and the vector is a vector have both value and direction. After that, I have also read about three equations of motion: v is equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2s. That's all, sir.
Very nice.
So you are in class 9.
Yes, sir.
Yes, sir. Pius and Ankur is class 9. Yes, Pius, which chapter you completed in science? Can you say something regarding this? Hello, Pius.
Yes, sir.
Can you say something regarding those chapter in science you completed before summer vacation? Few things.
Okay, sir. I am reading. I am reading of chapter 2, cell, the building blocks of life. So, cell. A cell is a basic structural and functional unit of life. All living organisms are made up of cells. Discovery of cell. The cell was discovered by Robert Koch in 1665 wheel observing thought under a microscope. Type of organism. Unicellular organism made up of one cell, example amoeba. Multicellular organism made up of many cells, example human beings. Shape of cells. Cells have different shapes according to their functions. Example nerve cell, long and branched. Red blood cell, round and flat. Parts of a cell. Cell membrane. Outer membrane of the cell protects the cell, control movement of substance in and out. Cytoplasm, jelly-like substance inside the cell, contains cell organelles, site of many chemical reactions. Nucleus, control center of the cell, contains chromosome and genes. Control cells active and hereditary. Cell organelles, mitochondria, produce energy for the cell, now has the powerhouse of the cell. Plastids, present only in plant cell. Cycloplast contains chlorophyll for photosynthesis. Plant cell, difference of animal cell. Plant cell wall present cycloplast present large volule fixed shape. Animal cell was absent. Chloroplast absent. Small vacuole irregular shape. Cell wall present in plant cell. Leaf shape and protection. Chromosome. Thread-like structures inside nucleus. Carry heredity threads from parent to offspring. It is done, sir.
Very nice. So now Earth,
Yes, sir.
because kids have no any question. One second. Yes, Earth, which chapter you completed in science before summer vacation? Can you say something?
I completed a chapter called The Changes Around Us.
Okay, so please say something regarding this.
So in this chapter we studied about like changes, how changes cures, what type of changes like physical and chemical, periodic, non-periodic.
Hello, sir.
So done, Earth.
Hello,
Hello,
sir.
Aryan.
Hello, sir.
So Aryan, it's the same question for you before summer vacation. In science, which chapter you completed? Can you say
Sir,
something? Can you say something? Yes.
sir, it's about magnets. We talked in the chapter. We talked about the heating effect of electric current, the magnetic effect of electric current, and how an electromagnet is formed, and uh, how and what are the strengths. What decides the strength of an electromagnet? Sir.
So Ankur, you have any question regarding Pew said something, or Earth has said something, or Aryan said something? You have any question? Or any students have any question?
Yes, sir.
Yes, sir. I have a question.
Okay, Piyush, 1 minute, Aryan.
Sir, I have a question of why is the cell called the structural and functional unit of life?
Can you repeat the question?
Why is the cell called the structural and functional unit of life?
Cell is the functional unit of, because
Yes, sir.
that is the smallest place where everything happens. Smallest unit in a body where everything happens. So each cell can survive on its own. That is the reason you have unicellular and creatures also, because a cell in itself has all the required function for any part of our body to survive. So it generates its own energy, it does its own defense mechanism, everything happens within a cell.
Okay, sir.
मम्मी से बात कर मम्मी से बात कर हाँ
So, uh, hello, sir.
Yes. Yeah, go ahead.
So, sir, I wanted to present something. Can I present?
Yeah, you can. Pankaj will help you with the presentation.
Okay,
Thank you,
so
sir.
we have seen one second, Aryan. Here we have seen first time Satyajit something. Yes, Satyajit, can you say
Sir,
something about yourself?
He has joined before. He's from my group.
Okay, okay.
Okay, sir.
for India is that one.
So, sir, it's about special and general relativity. So, introduction to relativity. So, Einstein's theories revolutionized our understanding of space, time, and gravity. They describe how objects behave at high speeds and in strong gravitational fields. These theories have been confirmed through numerous experiments and observations. Historical background: special relativity was proposed by Albert Einstein in 1905, and general relativity followed in 1950 as an extension to include gravity. Prior to Prior to Einstein, Newton laws dominated the understandings of physics. So, the special relativity stands for special cases where there is no acceleration and no gravity. And in general relativity, general means uh, more generalized, which includes acceleration and gravity. Why do we need special relativity? So, special relativity resolved the conflict between Newtonian mechanics and Maxwell's electromagnetism. Uh, Newton suggested speeds are relative, but Maxwell showed light speed is constant. When the Michelson-Morley experiment failed to find a space ether, Einstein realized time and space must be flexible to keep the sound speed of light absolute. So there were a few scientists. They were trying to find the space ether. People back in the day believed that light traveled in a space called ether, but when they didn't find it, they gave the uh, equations we know now known as length contraction and time dilation. So they said that length the length of a planet deviates and the time dilates so perfectly that we cannot find this space ether. So but people realize that if we can't discover it, how will it be even proven? So the space ether theory was uh, then out of the stage, and now these are used in relativity uh, by Einstein. The postulates of special relativity: the laws of physics are the same in all inertial frames of reference. The speed of light in a vacuum is a constant for all observers regardless of motion. These postulates led to non-intuitive effects like time dilation and length contraction. So it says that the speed of light isn't constant for all observers, regardless of motion. So let's s- like if a spaceship is flying and there is light traveling besides it, what would happen that the length of that ship will contract, and the time will dilate. It means that the 1 second in the spaceship would be different from our frame of reference, so that all that would lead to the speed of light being conserved. Time dilation. So moving clocks run slower compared to stationary ones observed from an inertial frame. This effect has been experimentally confirmed with atomic clocks on aircraft. Time dilation is significant at speeds close to the speed of light. So moving clocks run slower when measured to stationary ones from an inertial frame. So length contraction. Objects moving at relativistic speeds appear shorter along the direction of motion. This contraction only becomes noticeable at speeds approaching the speed of light. It results from the Lorentz transformation that relates space and time coordinates. The Lorentz transformations. So these equations connect space and time coordinates between different inertial frames. They replace the classical Galilean transformations at high velocities. Lorentz transformation predict phenomena like time dilation and length contraction. Mass energy equivalence. So Einstein's most famous equation is E is equals to mc square. It shows mass can be converted into energy and vice versa. This principle underpins nuclear reactions and particle physics. The concept of space-time. So space and time are interconnected into a four-dimensional continuum. Events are described by coordinates, three for space and one for time. The fabric of space can be curved by mass and energy. So, so in Newtonian physics, what they believe is that the ground is stationary, and if we fall from an height, what Newtonian physics would say that we are accelerating down towards the Earth, but Einstein says that's not that there is one another way is to imagine that the ground is accelerating up, and like if I'm standing, I will be feeling my own weight because I would be feeling the force in the opposite direction, and that is why we feel gravity. And this can also explain why light curves when on very high gravitational bodies. What happens that the ground accelerates up, and the light travels in a straight line, and because of that we see it curve. So there are concepts like world line here, which which Einstein used to explain why things like when an asteroid gets near the Earth, they'd stretch, and he solved it by using geodesics. So these world lines are parallel, but in a curved space time. Like on a globe, what would happen if we want to go parallelly so that the distance would remain a constant? What would happen? We have to increase our distance between them, because the curves will, if we travel on a globe, will eventually meet, and if that happens on a saddle, we'll eventually go far. So in a saddle we have to get closer to maintain the same distance. So that happens in uh, Newton, Einstein physics. So that is how he explains that an asteroid gets stretched when it's near Earth. Introduction to general relativity. So general relativity extends special relativity to include gravity. It describes gravity as the curvature of space-time caused by energy, mass and energy. Massive objects cause space-time to bend, affecting the motion of objects and light. General relativity. So general relativity relates. offer versatile and low cost for standard switching tasks in common appliances. Special purpose relays provide optimized performance and durability for extreme environments such as high frequency signals or heavy industrial roads. One good way, one good example of general relativity is the GPS signals that we get. So use the equivalence principle. So the equivalence principle states that gravity and acceleration are locally indistinguishable. An observer in a windowless room cannot tell if they are getting pulled by gravity or they are accelerated through space. This insight allowed Einstein to generalize special relativity into general relativity, reimagining gravity as curved spacetime rather than a force. So the equivalence principle is valid at only local scales where the gravity is uniform and where the gravity is non-uniform, this equivalence principles break. Gravitational time dilation. So gravitational time dilation means time moves slower where gravity is stronger. According to the equivalence principle, being deep in a gravity well is like a constant acceleration, since acceleration affects time in special relativity. Generalizing to general relativity reveals that the clocks on Earth tick slower than those in space. The Einstein field equations. These equations relate the distribution of mass energy to the curvature of space-time. They are highly complex but form the core of general relativity. So solutions to these equations describe phenomena like black holes and expanding universes. So gravity has geometry. So unlike Newtonian gravity, which is a force, Einstein described gravity as geometry. Objects follow geodesics or the straightest path possible in curved spacetime. This explains why planets orbit stars and light bend around massive objects. So, experimental evidence for general relativity, the shift of Mercury's orbit confirms predictions. Gravitational lensing observed when light bends around massive objects. The detection of gravitational waves from merging black holes supports the theories. Black holes. So, black holes are region of space-time with gravity so strong that nothing can escape. They form from the collapse of massive stars. Black holes demonstrate extreme curvature of space-time. Gravitational waves, so ripples in space-time caused by accelerating objects, first detected by LIGO in 2015, confirmed a key prediction of Einstein's general relativity, cosmology, and the universe. So, general relativity underpins our understanding of the universe's expansion. The Big Bang theory, supported by the metric expansion uh, described by Einstein, dark matter and dark energy, are phenomena explained within this framework. And why does gravity bend light? So, gravity bending light isn't about a force pulling on photons. Instead, it's an inertial effect because an observer is constantly accelerating upwards. Light appears to curve down. This insight helps us solve the mystery of why gravitational and inertial masses are identical. Can we outrun light? No, we cannot outrun light, but relativity dictates that you must always travel slower than light. However, by constantly accelerating, you can create a relentless horizon. This effectively leaves behind a patch of space-time where light rays can never catch up to you, mimicking a black hole's event horizon. The picture you see is of a future light cone and the past light cone. So it's a four-dimensional Minkowski's space-time diagram. So it's also the future light cone is you see is also of an photon. So they travel at 45 degrees. So relativity of simultaneity. So it means that now is subjective and depends on the observer's motion because world lines tilt due to relative speeds. Observers disagree on the timing of distant events. This highlights why coordinate maps can be misleading when describing black hole horizons and distant spacetime. This explains why one thing that we see right now may not be true for someone else. Like if so, it says that things that happen very far are of no significance to us because time is subjective and depends on someone's motion. Future light cone. So the future light cone defines the limit of a reachable space-time. Because light travels at 45 degrees, you cannot move outside this cone without exceeding light speed. In black holes physics, mapping this cone helps distinguish between events that can escape the horizon from those that are trapped. So as you see in the diagram, in the green, if we, for example, if we take the green patches, they are hyperbolas, and if let's assume that one there is an spaceship on the hyperbola and it's accelerating, and to that middle point, what would happen that it would appear as an hyperbola, and if it's just the right distance away from, like one step away from, it would be an asymptote. The light would be an asymptote to that hyperbola of that spaceship, and it will touch it at infinite time. But if it's farther from it, what would happen that it would never reach, if it would never reach the spaceship, which means that we can outrun light, but like we cannot travel faster than it, but we can outrun light. Everything moves at light speed. In everything, in space time, everything moves at a constant speed. C. If you're stationary, your full velocity spent through time. As you move faster than through space, your motion through time slows down. Time dilation and massless photons use all their speed in space effectively, experiencing no time. Events that never happen. Events inside a black hole are physically real but exist outside our observable timeline. While an outside observer sees an object take infinite time to reach the horizon, this is a limitation of the coordinate system map, not a physical reality. Once inside, the geometry shifts. Moving towards the central singularity becomes an inevitable time-like feature. Additionally, an infalling observer does not see the entire future of the universe. They eventually lose contact with all the external signals. So it's like if there's an ant on the table and there's a coordinate system, we draw one line and after that we have the distance and draw another line. What would happen that it would never actually reach the ant, but that ant is there. So it means that events that happen inside a black hole are never in a past, future, or present. They happen outside our timeline, space-time interval. So this equation describes the space-time interval. It says that our budget for motion is shared between time dt and space dx. So if you move through space, your passes through time d tau must decrease to keep the interval consistent. At light speed, space movements equal coordinate time, making proper time zero. In general relativity, it has metric tensors to for gravity or acceleration. So it is the equation is d tau squared is equals to dt squared dx squared plus dt squared. So if you move fast in space, what would happen that your proper time would get uh, would be more like less. So that is, so these are all the reasons for space time uh, or time dilation, you can say. These are just a byproduct of space time interval. Summary of special relativity. Special relativity deals with objects moving at constant high speeds. It introduces concepts like time dilation, length contraction, and mass energy equivalence. The theory relies on two fundamental postulates about the invariance of light, speed, and physics laws. Summary of general relativity. General relativity describes gravity as the curvature of space-time caused by mass and energy. It explains phenomena from planetary orbits to black holes. The theory has been validated through numerous experimental observations. So, sir, I'm done with the presentation. So, ladies and gentlemen, do you have any questions? Any questions?
Talked about time in the black hole.
Yes, sir.
So, so why is different?
Uh, why it's different? Events inside a black hole, so they never happen uh, in our world line. So they exist, but they do not exist in our timeline. Like they do not happen in our future, present, or past. So that makes many other questions like how is it formed and how does that person fall in the black hole because it takes infinite time. So one reason is because of relativity of simultaneity. It says that things that happen far away from us have no physical significance to us. So, sir, did I answer the question?
Okay, I'll put it more simply. The higher the gravity, the slower the time moves. Gravity actually bends the time. So the near the black hole, since the gravity is so much that the time moves extremely slow.
Yes,
That
sir.
means maybe an hour at near black hole could be a millennia at Earth.
Yes, sir.
So that is the yeah. So higher the gravity, slower the things move.
Yes, sir.
Good.
Okay. So, uh, uh, are there any further questions?
I think good.
Okay, sir.
Anyone else has a question?
Aryan, you have any question today?
Yes, sir. So, I had a question. So, why do things stick?
Why do?
Things stick. Uh, like if I keep my hand and it does not move, so it gets stuck to it. So, how does that happen? uh, said like I'm asking on the molecular scale. So how is that thing happening? If I'm touching the hand and its molecules get attracted to me, and then it should have formed another substance, and maybe that substance would not have gripped my carbon atoms. So there wouldn't be any stickiness at all. So why does that happen?
Okay, so if you look at molecular states, what happens is there is electrostatic attraction because some molecules acquire positive and negative charges. So they work as a tiny magnet. So they get stuck together. That happens at the molecular level.
Okay, sir.
So, Piyush, you have any question? You listen Aryan speech continuously. Hello, Piyush.
No, sir.
You have no any question?
No, sir. I have no question.
Okay.
If no one has a question, then I have some work. So I'll leave that case.
Okay. Okay, sir.
Okay, bye. Good night.
Bye. Good night, sir. Okay, Aryan, Piyush. Bye bye.
Bye,
Good
sir.
night, sir.
Good night.